What an absolute privilege to receive a tour of the Brisbane processing facility of Lifeblood, especially being able to geek it out as a curious process engineer and passionate blood donor. From start to finish, it was a beautifully streamlined process run by an intelligent team, proud of their life-saving work and happy to entertain my 1,001 questions. In fact, this centre receives over 1,000 bags of blood, plasma and platelets by road and air from Queensland and the rest of Australia every day. Everything's under critical temperature and time control to ensure the quality of the blood is maintained to higher standard. For example, apheresis plasma donations must be processed and frozen within 5.5 hours to be used for a clinical plasma transfusion. So Lifeblood coordinate multiple pickups from local centres each day and then use rapid plasma freezers at minus 42 degrees to freeze plasma in only 30 minutes. Depending on the type of donation, blood group, and time since donation, they're then categorised into products. I actually didn't realise that most blood isn't used directly as a transfusion, but processed first. Though now it makes so much more sense, as you would often want to remove components to optimise the treatment for the patient's needs. For example, if a patient has clotting issues and needs blood, then you don't want to give them more clotting components, platelets. So, by separating the blood into various components and applying different processes, they can significantly increase the efficacy of treatment and also utilise the various components across more patients. They even irradiate some bloods with X-rays to denature the DNA on the white cells to stop them proliferating when in the recipient's body. So this can prevent the graft versus host disease. It's absolutely incredible. They can use a centrifuge, which spins at 4,200 revolutions per minute to take advantage of the different densities of whole blood components, which can separate it into red cells, plasma, and something they call a buffy coat, which is what contains the platelets. Then, once it's separated, there's a finely controlled press, which squeezes out the plasma, and then also separately the red cells, which, while getting processed, needs to be agitated to prevent clotting, leaving only the buffy coat. And for those donors that have ever wondered why there are so many bags attached to the kits at the donor centres, it's because they keep it as one sealed, sterile kit from donation through to this separation process. The red cells are passed then through a filter to remove the white cells, also known as leukocytes, which is part of the donor's immune system. And these could be treated as a foreign body by the recipient's immune system. They can take 4 bags of buffy coats of the same blood group and combine them together to make a pooled pack. This is to get the volume up. They then spin it again and extract the platelets, and then they sample for bacterial contamination. Really cool process. It's actually warm. They have a couple of samples, one aerobic and one anaerobic. So they test for bacteria that can survive in oxygen and without it. They incubate them to try to grow the bacteria, and then they can test if there's any present. And if need be, recall the products through their comprehensively tracked product barcode system. Every donation also has a minimum of 3 tubes taken at time of donation for testing, and sometimes more, depending if it's a first-time donation or for risk factors identified on the questionnaire or previous blood donation profiles. So the testing department was amazing to see, and they had an automated tube transport machine that tracks all of the tubes as it tests them and even balances the load in the centrifuge for the variable sample sizes in each tube. They're color categorized, so the pearled lid tubes are for the nucleic acid testing of viruses. The older virus testing technology had to wait for our bodies to first produce the antibodies and then look for these. But now they test directly for the nucleic acid of the virus, meaning that viruses can be detected in the blood much earlier, days earlier even, than before the antibody type testing. They use specialized reagents and even tiny magnet beads, which have synthetic biological probe in quite a high-tech process to match the molecular geometry of the viruses. As you can tell, I really did geek it up and found this just truly amazing. They use the pink tubes for testing the blood group. This is done every donation. Now, there are 8 main groups, though there are over 360 blood groups because of different antigens, which form more complex profiles, meaning that even occasionally call-outs are requested for donations from particular ethnicities to have a better chance of a closer antigen match for patients in critical need and to minimize the chance of a reaction to the donated blood. The purple lid tubes, they're assigned to testing for red cell antibodies, including anti-D, which actually 17% of pregnant women need to prevent their immune system from attacking the red cells of their rhesus D positive baby. Now, currently, there's only about 100 anti-D donors in Australia rolling up their sleeves that are supporting 1 in 6 pregnancies. I found that fact incredible. If you haven't donated before, you should try, as you might potentially be an anti-D donor and can literally save babies' lives. There's also about 3 to 4 tonnes per week, just from Brisbane alone, of frozen plasma that gets sent to CSL, who then convert it into 18 different life-saving products for some uses including clotting factors and immune deficiencies. These then get stored back at Lifeblood before being distributed to the hospitals so they can improve the well-being and save lives of patients. So the dispatching team that manages all of this, they run 24/7 to ensure that the hospitals in their district get what they need when they need it, including some urgent life-threatening orders, which are shipped in specific temperature shippers within 30 minutes. To sum this up, because it was really technical and so interesting and almost overwhelming, I want you to think of like a video game where you might see 1,000 players carrying little differently coloured hearts, let's call these the life points, throughout this facility, each needing to ensure optimal movement, right, agitation or rest, and temperature, whether it's cool or frozen, while completing their different obstacle courses of processing to reach the finish line or before the timer runs out. And I'm so grateful for this incredible experience, and I'm very happy to be able to share this sneak peek inside the processing facility with you. I hope you've enjoyed this virtual tour and have a greater appreciation for the life cycle of the little bag of goodness that about 3% of Australians so generously donate.